Hello students, welcome to the physics guide. In yesterday's class, we have discussed about the buoyant force. Today we will discuss about the same but in detail. So we have earlier studied that buoyant force is the upward force given from a fluid to an object and its direction is always upward and it opposes the direction of gravitation. Now when an object is immersed in the water, so basically two forces are acting here. One is the force, that is gravitational force, which gives the concept of weight of the object, that is W equal to mg, and another this upward force, that is called the buoyant force. Now these two forces are in opposite direction, that is they are opposes one another. That's why this weight is getting reduced by this buoyant force. So whenever any object is dipped inside the water or any fluid, it becomes lighter in weight. I am talking about weight, not about the mass. So be careful about that. Now the apparent weight of the object is equal to the original weight minus the buoyant force. Since this original weight is reduced by this buoyant force, hence the object immersed in the liquid gets lighter. That is, weight is reduced. Now, how can we measure the buoyant force? We can write the buoyant force FB is equal to V into G into rho. Whenever the object is dipped in the water, always it pushes or it displaces some water. That is, if I immerse this object inside the water, it displaces some amount of water. Here, if we collect the water, okay. So the volume V, this V indicates the volume of the water displaced by the object. So we can write V is the volume of, rather instead of water we can write fluid. V is the volume of the fluid displaced by the immersed object. So V is the volume that is displaced by the immersed object. What is G? We know G is the gravitational acceleration. And what is the rho? Rho is the density of the liquid. Now, this weight of this displaced water is exactly same weight, that is exactly same as the buoyant force. So we can write or we can say that the buoyant force can be expressed as the product of volume of the liquid that is displaced by the object, gravitational acceleration, and the density of the liquid. So we can write here if B equal to V into G into rho, that is buoyant force is the product of volume of the liquid displaced by the object, comma, gravitational acceleration and the density of the liquid. Okay. Now, the water which is displaced by the object, that weight is perfectly equal to that buoyant force. That means if here is the object dipped inside the water, and suppose this object displaces some water here. Okay, we are collecting the water. Now, if this weight of the water is suppose 10 unit. In 10 unit, the weight of the water. That means this is equal to the buoyant force. That is, if we measure the water weight, if it is 10 unit, then we can say that buoyant force is also 10 unit. That's why we can say that the weight of the water displaced by the immersed object is equal to the buoyant force. That is the force given to the object. That is, if this water is 10 unit its weight, then the buoyant force is also equal to the 10 unit. And we can say this is the Archimedes principle. So we can write what is Archimedes principle. We can write here. Let me clean the board. So we can write the Archimedes principle as the fully or partially submerged object in a fluid experiences force, that is buoyant force, upward buoyant force, which is exactly equal to the weight of the water displaced by the object. So this is the Archimedes principle, and based on this we can go forward. That is, we can write again. Already we have written this. Again I am giving you something, showing you something. Wait. This is the buoyant force acting in upward, and the displaced water here. We are collecting the water here. Okay, and we can write that is the apparent weight of the object, apparent weight of the object is equal to the, we are considering about the weight of this object, apparent weight of this object that is submerged inside the water or liquid, equal to the original weight minus the buoyant force. So if the original weight, suppose it is 200 unit, we can write it as 200 unit, and the buoyant force is acting upward, suppose this is 30 unit, so the apparent weight will be 170 unit. That's why the object 200 and it is the apparent unit, that's why the object inside the water, it will be, seems to be lightweight. And this 30 unit, this buoyant force, this is acting here 30 unit, this is equal to the weight of this water, that is if FB is 30, then this weight of the water is also 30 unit. Hope up to this you have clearly understood. If you have any confusion, you can watch the video again and again, and you should think about it. Actually, physics is a process where there are different ways to think a single matter, and so try all the ways to think, and if you have any doubt, any query, you can surely ask me. So thank you. Till then, I will be coming in the next class. Until then, bye.